Welcome to the 8th CJ tutorial. In this video I have planned a flight from Mannheim Echo Delta Foxtrot Mike to Freiburg Echo Delta Tango Foxtrot, and I want to talk some more about VNAV and also show you how to use custom waypoints in the UNS. I've thought about VNAV quite a bit in the last few days and I realized I did not explain it as good as I could have or should have in the video where I talked about the IFR flight. So I thought I'd go into a bit more detail and do a little ground lesson basically on what we want to do with VNAV, how we can do that in a CJ. Then I'll brief the flight, and after that I'll do the flight, and I think I'll leave it mostly uncut from takeoff to landing. It's a 25-minute flight and it's interesting. And as always, I will include the relevant timestamps so you can skip ahead if you want to. So let's have a look at what the problem is that we want to solve with VNAV. Let's say we're at some cruising altitude here, and let's say this is the ground, and we want to descend to some other altitude at some point. Let's call this point B. And now the UNS needs to calculate our top of descent. Our top of descent is the point where we start the descent in order to reach the point B at the given altitude. Well, if we just tell the UNS we want to reach that point at, let's say, 3,000 feet, then it cannot calculate the TOD for us because it does not know where. It has no clue how fast you want to descend or at what speed you want to descend. Yeah, so it's not possible. So we need to give it some more information. So what we do is we specify a descent rate. So I usually like to use 2,500 feet per minute. But also if we have that, we cannot really specify a TOD because it depends on our speed as well. So what the UNS does, it takes the current speed of the plane at the moment where we ask for the VNAV calculation or for the TOD calculation. It takes the current speed and calculates the TOD based on that. So let's say it comes up with this point. This is our TOD. Let's call that point A right here. And obviously what the plane will do, it will go like this. And then we will have this as our descent segment. Let's set aside the question how exactly the UNS calculated this TOD point, but let's rather look at that line that it calculated for us. So first of all, this line is called our glide path. And if we look at that, it has, well, it's a line, it has a x component and the y component, so to speak. So we have the distance between A and B right here. This is in the x direction. We could call that the difference in x direction, delta x. We also have the distance between our 3,000 feet and whatever our cruising altitude is. That's our delta in the y direction. So we have these two differences, and based on the ratio of that, we can calculate this angle right here, and this is called the glide path angle. Glide path angle, or I'll abbreviate it as GPA. Now, the glide path angle stays fixed as long as the TOD stays fixed. So even if our speed changes, as long as the TOD stays the same, so point A, then this angle will not change. We need to adapt our descent rate instead. Of course, we could recalculate the TOD if we change our speed, but that's not how the UNS does it. Once we calculate the TOD, it's fixed, and that's what we're going to assume in the following. Now, how can we keep track if we are on this glide path or not? Obviously, we do not have a glide path annunciator or whatever in our plane. We can just see our vertical speed in feet per minute, and we can see our normal airspeed in knots. So let's have a look at what the UNS gives us. Let's say this is our glide path, I calculated. It gives us what's called vertical deviation, or VDEF, and there are three situations that we can be in. So first of all, we are below the glide path, so that would be a VDEF that is less than 0. So for example, negative 100 feet or something. The other situation is that we are right on the glide path. That would be a VDEF of exactly 0, and this is what we basically want during the descent in the best case. And the other case is that we are above the glide path, and that would be a VDEF greater than 0. So obviously, if we just keep the glide path angle that was calculated, we will never reach our glide path again. So in the case of the VNAV being less than 0, we have to decrease our glide path angle in order to catch up. And if the VNAV is greater than 0, we have to increase our glide path angle in order to catch up. Question is, how can we do that? Well, there are two possibilities. We can either keep our speed constant and change our vertical speed, or we can keep our vertical speed constant and change our speed. So let's have a look at both of these scenarios. So let's have a look at the case where our speed is constant first. So let's say within 1 minute, with our current vertical speed, we lose this amount of altitude. And while we lose this amount of altitude, if we want to stay on the glide path, we have to move this amount forward. So this is after 1 minute our lateral distance, and this is our vertical distance. Now what happens if we increase our vertical speed? So instead of the upper one, we have now the lower one after 1 minute. The distance we cover in this minute stays the same, so it also goes until here. So our new reference point basically is here. And if we now plot the line through this point, we can see that our glide path angle increased. So what we can say here, our vertical speed is proportional to our glide path angle. If we now look at the other case, so we keep our vertical speed constant, but we change our airspeed. Let's have a look. Let's say this is our normal airspeed. So after 1 minute, we are here. What does that mean for our vertical speed? We now do the inverse. We look up here and we can see this is our vertical speed. We now keep that one constant. This is also for 1 minute. And now let's say we increase our speed. Instead of only going up until the left one, we now can go up until the right one in 1 minute. Now if we extend that over here and look at the intersection, we end up here. And if we plot a line through that, we can see that our glide path angle decreased. So we can say that our speed is inversely proportional to our glide path angle. It's helpful to have built-in intuition for this and to be able to modify your glide path angle with the vertical speed and the speed. All right, let's now brief the flight. Let's have a look at the route first of all. We are departing here in Mannheim, Echo Delta Foxtrot Mike. We'll fly a SIT to Rinex, then follow 2 airways to Lipka, and then go, well, first of all, plan direct Freiburg, Echo Delta Tango Foxtrot. So we're basically going north to south. The interesting thing about these airports is that Mannheim is a controlled airport and will depart IFR, but Freiburg is uncontrolled and is VFR only, so we'll have to arrive VFR. Before we look at how we arrive at VFR, let's basically talk through the whole flight from the departure to the arrival. So let's start with the Mannheim ground chart. We are situated somewhere here in front of the control tower. We only have one runway in Mannheim. Wind is 270 at 5, so runway 27 is in use. And we will taxi to taxiwheel Alpha, and then on lineup we have to be careful because there's this Foxtrot right here, the first one to the right. There's the actual runway, and behind the runway there's taxiway Delta, so we have to make sure we use the middle one to get to the actual runway. Other than that, no surprises in Mannheim. We'll have the Rinex 3 Whiskey departure, which has us climb out at 256. Then do a left-hand turn to Rinex, and we have a constraint here. We have to be above 5,000 at Rinex. The climb clearance is 5,000 feet. Now let's go to the flight plan. We will climb to flight level 180. Let's jump to the route first of all. The Rinex 3 Whiskey brings us to Rinex, obviously. Then we follow the November 850 to Karlsruhe, Kilo Romeo Hotel, and then Tango 715 to Lipka, and then we are flight direct Freiburg. In Freiburg, winds are calm and variable, so we will choose runway 16 that fits us better geographically. We'll have a look at that soon. Let's, while we're here, have a look at the other pages of the flight plan. So for the fuel, block fuel unit 1,520 pounds. By default, we have 1,610 pounds loaded, so that's more than enough. And for the final reserves plus alternate, it's 771 pounds. Speaking of the alternate, it is Baden-Baden, Echo Delta Sierra Bravo, runway 21 in use. And yeah, right, we just had. Speaking about the weather, you can see right here the flight plan's created on the 4th of January, so this is historic weather. So feel free to recreate this flight. It's 15 locals right now. Weights. Let's not worry about times, so let's jump right to the weights. We have one passenger on board. Bags cargo is 55 pounds. Zero fuel weight is 6,800 approximately. Takeoff weight 8,160. Landing weight 7,700. That's our route. As far as weather goes, Mannheim, we have 270 at 5 as I already said. Visibility more than 10 kilometers. Clouds broken 3,500. If you look at the sim right now, it's pretty cloudy. So we will not use the anti-ice on takeoff, but we'll have to use it during the climb. We have to activate it during the climb, I mean. Temperature is 1 dew point minus 5 QNH 1012. Weather for Freiburg looks a little weird. It's said to be the city in Germany with the most sun hours, but I doubt that it's 37 degrees Celsius in January. So this must be some historic weather data. If we actually look at the weather we get in the sim in Freiburg, we can see wind slight and variable, visibility more than 10 miles, sky is clear, temperature is 1 dew point minus 5 QNH 1012. And for Baden-Baden, our alternate, wind 210 at 6, visibility more than 10, few clouds at 3,900, overcast 4,400, temperature 1 dew point minus 4 QNH 1013. All right, continuing the weather charts. That's our route. That's our significant weather. We do not have any significant weather. That's also nice for change. Winds, we have quite significant crosswinds, but that's okay. And our vertical profile going from right to left, that looks also reasonable. All right, looking at the arrival into Freiburg right now. So this is a chart for Freiburg. If you look at the, first of all, runway directions are 16 and 34. We have this traffic pattern right here, which will be too small for CJ, so coming into 34 would not be a good option. We have quite some high mountains to the south of the field. We can also see that in the little nav map. That's Freiburg. If I switch over to the topo map, we can see that right here. So we want to have a direct approach onto runway 16 if possible. How can we do that? If we overlay the low altitude airways, there's Lipka, and we're coming from this. We're following the Tango 175, so we come from Denel. Let's add that to our flight plan. Nope. And then we continue Lipka. And then we have Freiburg as our destination. So at Lipka, we want to be VFR at latest. So we want to be at Lipka at a reasonable altitude. Let's say we are clear of clouds. Let's say 3,000 feet. Freiburg is at 800 AMSL. So we don't want to be 3,000 directly at Lipka because we want to be VFR there. We want to be at a reasonable speed for VFR. So let us define a waypoint a couple of miles before Lipka that we can use for our VNAV calculations. So let us measure a distance right here. We can see right here it's a 183 heading. So let us go for the reciprocal of that. So 3 degrees and 4 miles, and then we get this point right here. We can say we want to add a waypoint. Where's my waypoint 1, if I may ask? Oh, that's Daniel. Okay. So that's actually that. Okay, and that automatically changes name. Interesting. So this is our target for the VNAV. And then we also need to have some kind of, well, final approach fix, let's call it. We want to have an extended centerline, basically. So we can measure a distance right here. The reciprocal runway heading is 340. So let's just put a line 340 here. And then from libcar, we can go perpendicular to that. That should be 250 degrees. And at the intersection of these two, we can define yet another waypoint. And that will, if we clean up a bit here, give us a 7-mile final. These waypoints, waypoint 1 and waypoint 2, we can actually define in the FMS later. Let's look at the visual approach right here. We are following the highway first of all. That's a nice visual cue. There's this industrial area right here to the right of the airport, which is also quite prominent. And then there's the airport itself, of course. If we look at the ground chart of this airport, we can see we have a 3.5 degree glide slope, or we have a PAPI with a 3.5 degree glide slope, and the PAPI will be to the right of the runway in the 1-6 direction. Also, another thing, the turn-off, the last turn-off we'll have, we probably won't make Bravo. It's before the end of the runway, so we just have to keep that in mind. It would be embarrassing if we go all the way and then have to backtrack. And then we can go to the apron right here via Alpha, Mike, and I guess that's Bravo then. Runway length is 1,338 meters. That's 4,300 feet approximately. If you look at our TLD sheet, that's not the one. That's the one. There's our 4,300 feet available. You are using 2,150 feet with anti-ice off, 3,225 feet with anti-ice on. So I will go for anti-ice off for the takeoff, just so we have a bit more runway available. As far as takeoff data goes, we have a V1 of 99 knots, VR of 100, V2 of 104, VANR 115, VREF for the return 101. At Mannheim, takeoff weight 8,200, flaps 15, power with anti-ice off is 94%. For the arrival into Freiburg, QNH is expected to be 1012. VREF will be 98, we approach 105, we need 2,410. I just realized the 4,300 is of course for Freiburg, not for Mannheim. That does not make sense. Let's have a look at Mannheim. Real quick. For Mannheim, we have 3,500 feet. So if we look at 3,500 versus 3,200, there's not a lot of room in case of a aborted takeoff. So obviously, so we have 3,000, oops, that's the wrong thing. We have 3,500 available in Mannheim. We have 4,300 available in Freiburg. So back to the briefing in Freiburg. 4,300 available, we need 2,410, that's enough. Landing weight will be 7,700, flaps 35, and for the ground we'll also have 94%. Weather, I already told you, 4th of January 2026 at 15 local. That is the flight briefed, and I will see you at the FMS preparation. So FMS setup, flight plan, yeah, before the flight plan, let's actually go to fuel. The fuel weight is 6,800 and fuel on board is 1610. Okay, then let's go to the flight plan. We want to go to Echo Delta Tango Foxtrot. Message is considered. We will depart by runway 27, Renex 3 Whiskey. There's no transition. That brings us to Renex, and the route is quite straightforward. We'll go via November 850 to Karlsruhe, Kilo Lima, correction, Kilo Romeo Hotel, and continue via Tango 715 to Lipka. Okay, now remember, we have these two waypoints. We want to insert a waypoint before Lipka. So we click on the waypoint in front of which we want to insert a waypoint. So we want to insert something in front of Lipka, so we click Lipka. And then we give it a name that doesn't exist in the database. I happen to know that WPT and then a number doesn't exist. So WPT1, I call it. And if we hit enter now, we are brought to the define waypoint page. We can now define a waypoint based on a reference waypoint and radial, or with its coordinates. We'll use the reference waypoint. So reference waypoint is obviously Lipka. And yep, that one. And the radial we need is the 3-degree radial. So if we type in a 3, that will be the decimal place, so I have to actually input 30. That's the 3-degree radial, and the distance will be 4 miles, so input 40. And we can accept that, and now we see this waypoint is 4 miles away from Lipka, and the track right here is 183 for both. So that worked. The next waypoint, our final approach fix, so to speak, our extended centerline point, we want to insert before Lipka after the snow link, or after Lipka before the snow link. So we click the no link and we give it a name. Let's call it WPT2. And we're here again. So this one, remember, we defined as an intersection of two radials. So we need two waypoints. We have the Echo Delta Tango Foxtrot Airport as one waypoint. And we're going to use the 340 radial. Now we skip the distance, just hit enter. And now we have a second reference waypoint, which is Lipka. And from Lipka, that was radial 250. And that gives us the intersection right there. So if we accept that and we delete the discon, we'll see this is 7 miles in a 164 track. So that works out. So remember that we created this waypoint 1 in order to have the altitude constraint on it, so let's not forget about that. Let's give it a 3000 feet altitude constraint, and that's our flight planning done. Let's set this to standby. I'll see you before takeoff again. So real quick, I just boot up the FMS again after the engine start, and it came back to this, so as if I had it powered off, but I definitely put it to standby. This might be a bug. I could reproduce that the few times I've practiced this flight. I guess it has to do with the custom user waypoint somehow, but I'm not quite sure yet. Alright, below line, pitot static heat on, anti-ISDs will keep off. We have to turn that on after takeoff. Anti-collision lights go on, landing recog lights go to landing. We'll release the parking brake. Transponder goes to altitude reporting on 1000. Radar is not implemented, and the annunciator panel, well, that's considered. That's the thrust attenuators. The approach path is clear. The runway is clear. Let's go. That's the second to the right. And for the takeoff performance data, VR is 100, V2 plus 10, 114 is bugged, and that will be a 94% takeoff without anti-ice. So, turning right now, runway is identified. Let's go. That's for life. 80 knots. Rotate. Positive rate, gear up. And flaps up. And engaging the autopilot. Nav mode, vertical speed mode. Going up to 2000 feet a minute. And we'll keep the N1 at 94% for now. There's a turn coming up. Return ignition off now, NTI is on. Looking for a speed of 220, then we'll enable IAS. Waypoint coming up. Speed's increasing nicely. 220 knots, IAS mode. There's 8,000 to go. Let's continue the climb to flight level 180. There's 5,000. Altimeter standard. And we have an after takeoff checklist to do. After takeoff, landing gear is up, flaps are up, ignition is off, that's the anti-ice. Climb power is 94 for now, that's set. Right engine running a bit high. Engine synchronizers off, your lamp is on, passenger advisory switch will keep on through the clouds. Anti-ice is on, landing recog lights are on recog for now, pressurization is checked, and the auxiliary control valve is on normal, altimeters are set standard, landing lights still to go. So another left turn. Coming up to 10,000, we can turn off the landing lights. And we can have a look at our outside temperature. This is about negative 10 Celsius at flight level 100. That's not what I want to do. Performance, page 22 is our climb performance. Negative 10 at flight level 100 is 97% with anti-ice on. So I can actually increase power a bit. Not too much though. And once we made our turn to the right there, we can release the passengers and also turn our anti-ice off once we're sure if we go through this door or not in front of us. We do not have any virtual passenger support right now, but I still like to remind myself of operating the pack safety switch there. Also, I've done this flight 3 or 4 times now. And the weather is always a bit different, which might be because I get to depart at different times, but I think the depiction of the actual historic weather might be different. Turning right now, heading 182. And if we look at what's ahead, where, well, let's put our sunglasses on, we are definitely above the clouds now. So we can turn off the anti-ice and have another look at our performance table. We are 15,000 now at minus 10, so 15 at minus 10 we can go to 98.4 now, which our left engine conveniently already is doing. .4 on the climb, nice. And there's 1,000 to go. So as I hinted on in the VNAV explanation earlier, I'll first of all let the aircraft build up speed, and then once we're at cruise speed, I will calculate our top of descent. So leveling off now. We are at approximately level 200 with minus 15 degrees, so 200 minus 15. We could go to 99.1 if we wanted to. Performance-wise in the cruise, we will not need to do so because we'll overspeed at this power setting anyway. So already accelerating through 250 there. Let's reduce power to about 90%. In order to stay below 260. That's looking good. So let's go to the flight plan, not to the flight plan page, to the VNAV page, and enter our target vertical speed, 2,500 feet per minute. That gives us a TOD in 4 minutes. So let's prepare the descent to Freiburg. We'll have pressurization. Freiburg's at 800 MSL, so we'll input 1,000 here. We could find the dial. There we go. QNH will be 1012. Let's assume a transition altitude of flight level 70, or transition level rather. The landing lights already did. That is basically all we have to do for the descent preparation right now. Now we have the landing lights. Also, VREF will be 98 knots. VREF will be 98. So we're there. And V approach will be 105. TOD in 3 minutes. And we have a before descent check. No, it's called the descent checklist actually. Descent checklist. Defog systems are not required. Pressurization is set. Anti-ice systems will be required once we go through the clouds. That's considered. Throttles considered. If we want speed brakes and anti-ice between 85% and 70%. N1, correction N2. Altimeters will anticipate QNH 1012. Landing data we have set and briefed. And landing regression lights we leave off for now. That's the descent checklist complete. And now we'll wait for the TOD, or rather for this display to change. We have the message now warning us of our top of descent alert. So let us set our 3,000 feet target altitude right here. There we go. And now we'll wait for this distance to reach 0. Shortly before that, this display will change, and then we'll briefly talk about what we see there. Let's talk about what we see here right now. This is the target vertical speed from the TOD to reach the target waypoint at this specified glide path angle. This is the distance to our TOD, both in distance and time. And from our present position, if we were to descend now, we would have to do so at 1,883 feet. And this glide path angle right here to reach that point at 3,000. That's what we're seeing right now. And also, you can see that the glide path angle itself is staying constant, and but because our speed is changing, the target vertical speed is changing as well. Okay, we went into VPath mode. Let's quickly pause the sim and have a look at what happens here. So we can see our vertical deviation now. It's negative, meaning we are below our current glide path. And yeah, the other indications are basically the same. So this is the vertical speed we would need at our current speed right now in order to be on this 4.19 degree glide slope. And yeah, this is the one we would need from our present position to go there. If we want to catch up with the glide path, we would now have to be on a lower glide path than that one indicate. I'll just keep my current altitude and then wait for that to be at -100 or something, and then initiate my descent. So I'll go to vertical speed mode and set this to 0 feet per minute for now. And now we can see the VDEF is getting closer to 0. And now we're at 100. I'll go to 2,000. Let's make that 2,300 feet per minute. And decrease my power to about 60% N1 in order to not get too fast. And we'll also activate the NTS again, because we're getting into the clouds. We have now a positive VDEF, meaning we need to either increase our vertical speed or we need to decrease our speed. Let's decrease our speed and put out speed brakes and see what happens. Now you can see as speed decreases, our VDEF is getting closer to 0. Let's bring the speed brakes in again, because now we're getting below the glide path. Also, we're descending too fast now. We are going 2,000, or we should go 2,100 to stay on glide path. We were going 2,300, so I'm setting the vertical command for the descent rate to 2,000 right now. Set to 1,900. And let's try to keep the 240 knots through the whole thing. That makes it easier to work with the constant speed. Increase to -2,100 feet per minute now. Bit less power to keep the speed. And we're getting into the clouds for you now. Decreasing to 2,000 feet per minute, we're getting too low. Decreasing to 1,900. And we're getting into the cloud now. Yeah, peg safety was never off, but it's on now definitely, so that's good. Passing 10,000, we'll go landing lights on. And that should be the last cloud on our way down. We also have an approach checklist. Seat belts, shoulder harnesses, check the VNX flight instruments are set. Radar altimeter not applicable. Passenger advisory switches on passenger seats checked. Crew briefing is done. Fuel transfer is off. Engine synchronizer is off. The thrust attenuator switch is auto. Anti-skid switch is on. Landing lights are on. Announcer panel is clear. Landing at airports above 10,000 feet. Skip. Pressurization is set. And flaps defer. That's the approach checklist completed. Turn on the ignition now before I forget. Speed's still looking good. We can now go to QNH 1012 for landing. And we have come quite low while doing so on our descent profile. So let's try to fix that. Going to 1,700 feet per minute now, which seems to help. Back to 1,800. And there's 1,000 to go. Yeah, frames are horrible with the recording running there. And there's 3,000 feet coming up at 0.2 nautical miles to the fix. That's nice. We'll cancel the VNAV now. Go to heading mode. We want to be VFR soon. So let's prepare for manual flight. I like to do manual flight in the VFR condition right there. We can also squawk VFR by hitting this. We squawked 7,000, which is VFR in Germany. We'll decrease our speed. Autopilot off. And flight director off. And we'll now turn right, heading 250. We can set 160 runway heading here. On the heading bar, we'll descend to 2,000 feet. While doing so, right 250. Can use the speed brakes here to help a bit. Flaps down, speed brakes in. 2,000 feet coming up, there's the highway. Want to follow to the left to the airfield. There's the industrial area ahead. We can see 4 red poppies. You can go get down now. That's 3 green. Keep the 2,000 trim for that. Want to be to the left of the poppy, so correct to the left a little bit. And wait for the whites to come in. We have a before landing checklist, ignition, landing gear, flaps pressurization, autopilot, yaw damper, airspeed, and speed brakes. That's all considered. Before landing checklist complete, flaps still to go. Well, it's not complete then. So, yeah. That's 1 white. Let's go flaps full now. Flaps 35. Going to approximately 110 knots, VRF plus 10. We have 3 white now. And reducing to VRF. Still a bit high. Okay, and power to idle, we'll glide the rest in. Bit of long landing there, flaps ground. And decelerate. Alright, welcome to Freiburg. I'll see you once we're parked and shut down for the debrief. Alright, we are parked. I think that flight went pretty well. I realized during the taxi that I forgot to turn off the anti-ice during the approach, but other than that, I am happy with the flight. I hope I was able to show you a little bit more on how to operate VNAV, how to actually plan your descent and execute your descent, and also that this flight itself was fun. In the next video, we'll have a look at go-arounds and holdings and possibly also diversions. See you then.